Hello and welcome to our SIAM course on power generation technologies. My name is Kundan Sahu, lecturer in mechanical department from Uday Prasad Uday Government Polytechnic, Durg. This is the diagram of nuclear reactor. In this diagram, heat exchanger is there, control rod, steam generator is there, pump is there. So, this is the main diagram of nuclear reactor. Let us discuss about this diagram. Under nuclear reactor, fuel element is there. The nuclear fuels which are generally used in reactors are 92 uranium 235, 94 plutonium 239 and 92 uranium 233. Out of the three, the 92 uranium 235 is only naturally available up to 0.714% in the uranium ore 239 and remaining is 92 uranium 238. 92 uranium 235 is unstable and capable of sustainable chain reaction. Under nuclear reactor, natural uranium contents are there. What is natural uranium? Natural uranium refers to uranium with the some isotopic ratio as found in nature. It contains 0.711% uranium 235, 99.284% uranium 238 and a trace amount of uranium 234 by weight 0.0055%. Approximately 2.2% of its radioactivity comes from uranium 235, 48.6% from uranium 238 and 49.2% from uranium 234. Enriched uranium. So, what is enriched uranium? It is a type of uranium in which the percent composition of uranium 235 has been increased through the process of isotope separation. It has two types. First one is low enriched uranium, second is high enriched uranium. So, let us discuss about the low enriched uranium. Low enriched uranium has a lower than 20% concentration of uranium 235. For instance, in commercial light water reactor, the most prevalent power reactor in the world, uranium is enriched to 3 to 5% uranium 235. Slightly enriched uranium has a concentration of under 2% uranium 235. Next point is high enriched uranium. Highly enriched uranium has a 20% or higher concentration of uranium 235. The fissile uranium in nuclear weapons primaries usually contains 85% or more of uranium 235 known as weapon grades. The other two fuels 94 plutonium 239 and 92 uranium 233 are the byproduct and formed in the nuclear reactor during fissioning process from 92 uranium 238 and 90 thorium 232 due to absorption of neutron without fission. The fuel is shaped in various shapes like rods, plates, pellets, tins, etc. and located in the reactor in such a manner that heat production within the reactor is uniform. The uranium fuel is formed into ceramic pellets. Pellets are in cylindrical shape whose diameter is 2 centimeter and height is 2.5 centimeter. Each ceramic pellet produces about the same amount of energy as 150 gallons of oil. These energy rich pellets are stacked end to end in 12-foot metal fuel rods. A bundle of fuel rods, some with hundreds of rods, is called a fuel assembly. A reactor core contains many fuel assemblies. The fuel elements are designed taking into account the heat transfer, corrosion and structural strength. Let us discuss about the moderator. It is used inside the nuclear reactor. So, it is a material used to slow down the neutrons from high kinetic energy, that is 1 million electron volt or 13,200 kilometer per second, to slow neutrons, that is 0.25 electron volts or 2200 meter per second in a fraction of a second. The function of the moderator is to increase the probability of reaction. The fission chain reaction in the nuclear reactor is maintained due to slow neutrons when the ordinary uranium is used as fuel. The moderators are lighter than fuel. Various materials used for moderator are ordinary water, that is H2O, deuterium or heavy water, that is D2O, graphite and beryllium. The graphite, heavy water or beryllium can be used as moderator with natural uranium. The ordinary water H2O is used as moderator only with the enriched uranium. Following properties of good moderator. First one is it must be light as possible. The slowing down action is more effective in elastic collision with light element. Second property is it must not absorb neutrons during slowing down them. It must be able to work under high pressure and high temperature with good corrosion resistance. It must have high chemical stability as well as it should not be decomposed due to the nuclear radiation. Next point is reflector. It is also the part of the nuclear reactor. It is important to conserve the neutrons as much as possible for reducing consumption of fissile material and to keep the size of the reactor small. This is possible by surrounding the reactor core with a material which reflects escaping neutrons back into the core. The material is called reflector. The required properties of a good reflector are low absorption and high reflection for neutrons, high resistance to oxidation and irradiation as well as high radiation stability. The material used for moderator are also used for reflector, example H2O, D2O and carbon. It is necessary to provide some method of cooling the reflector as it gets heated due to collision of neutrons with its atoms. Under nuclear reactor, next point is coolant. The main purpose of the coolant in the reactor is to transfer the heat produced in the reactor and to keep the fuel assembly at a safe temperature to avoid their melting and destruction. The same heat carried by the coolant is used in the heat exchanger for further utilization in the power generation, either generating steam or using hot gas. Different properties of good coolant. So, these are as following as first one is it should not absorb the neutrons, it should have high chemical and radiation stability, it should be non corrosive, it should have high boiling point if liquid and low melting point if solid. It should be non oxidizing and non toxic. It should have high density, low viscosity, high conductivity and high specific heat. The water, heavy water, gas, that is helium, CO2, a metal in liquid form, that is sodium, and organic liquids are used as coolant. Under nuclear reactor, next point is control rod. The control rods control the rate of energy generated. It starts, increases, decreases and stops the reaction. These rods may be shaped like the fuel rods themselves and are interspread throughout the reactor core. Instead of containing fuel, they contain neutron absorber such as boron, cadmium or indium. They have high neutron absorption cross section. The control is necessary to prevent the melting of fuel rods, disintegration of coolant and destruction of reactor. The amount of energy released is enormous. The control rods can be moved in and out of the reactor core assembly either automatically or manually. The magnitude of insertion of control rod represent the proportionate absorption of neutrons. Next point is biological shield. Shielding the radioactive zones in the reactor from possible radiation hazard is essential to protect the human life from the harmful effect. The common radiations from the reactor are alpha rays, beta rays, gamma rays and fast neutrons. To prevent the effects of this radiation on the human life, it is necessary to absorb them before emitting to the atmosphere. Shielding consists of inner lining of 50 to 60 centimeter plate on the reactor core called thermal shield with a few meter of thick concrete wall surrounding the inner shield called biological shield. The lining of steel plate absorbs these energies and becomes heated and prevents the adjacent wall of reactor vessel from becoming heated. The thermal shield is cooled by the circulation of water. Next point is reactor vessels. The reactor vessel encloses the reactor core, reflector and shield. It also provides coolant inlet and outlet passages. The reactor vessel has to withstand the pressure at 200 bar and above. The reactor core, that is fuel and moderator assembly, is generally placed at the bottom of the vessel. Next point is reflector. It is important to conserve the neutrons as much as possible for reducing consumption of fissile material and to keep the size of the reactor small. This is possible by surrounding the reactor core with a material which reflects escaping neutron back into the core. This material is called reflector. So, in order to obtain critically or steady power, three methods are used. Building a heterogeneous reactor. A heterogeneous reactor using natural uranium or low enriched fuel is one in which the fuel must be divided into separate fuel elements in the form of pins, rods, plates, hollow cylinders, pellets, spheres, etc. These are placed in the core with space between them filled with moderator. Second method is enriching the fuel. The second method of attaining critically is to enrich the fuel by artificially increasing the percentage of uranium 235 in it. Ordinary water, often incorrectly called light water, may be used as moderator, resulting in thermal heterogeneous reactor. In last method, we use both methods. Next point is steam generator. It is important elements of the nuclear power plant. Steam generator are heat exchangers used to convert water into steam from heat produced in a nuclear reactor core. Heat exchangers that transfer heat from the reactor coolant to a separate water loop, producing high pressure steam to drive turbines. Next one is steam turbine. It is also important components of the nuclear power plant. The steam produced in steam generator drives a turbine which is connected to a generator. Steam turbine is a mechanical device that extracts thermal energy from pressurized steam and converts it into useful mechanical work. As the turbine spins and it generates electricity, various high performance alloys and super alloys have been used for steam generator tubing. Next point is coolant pump. The coolant pump pressurizes the coolant to pressures of the order of 150 bar. The pressure of the coolant loop is maintained almost constant with the help of the pump and pressurized unit. Next important element is feed pump. Steam coming out of the turbine flows through the condenser for condensation and recirculated for the next cycle of operation. The feed pump circulates the condensed water in the working fluid loop. Condenser, it is also used in nuclear power plant and it is important elements of the nuclear power plant. Condenser is a device or unit which is used to condense vapor into liquid. The objective of the condenser are to reduce the turbine exhaust pressure, to increase the efficiency and to recover high quality feed water in the form of condensate and feed back it to the steam generator without any further treatment. Next important component is cooling tower, a system that dissipates the excess heat generated by the condenser. It can use various cooling mediums such as cooling towers, rivers or oceans. Cooling towers are heat removable devices used to transfer process waste heat to the atmosphere. Water circulating through the condenser is taken to the cooling tower for cooling and reuse. Emergency cooling and safety system. It is important elements of the nuclear power plant. Multiple backup systems designed to cool the reactor and ensure its safety in case of abnormal events or emergencies, such as loss of coolant or power. Next component is control room and instrumentation system. The central command center where operators monitor and control the plant's operations, safety system and power generation processes. A network of sensors, instruments and control system that monitors and manage the plant's operations and safety parameters. Next important element is waste storage and disposal. Facilities for storing and managing radioactive waste generated during the plant's operation. This includes spent fuel rods and other nuclear byproducts. Next point is auxiliary power system. Backup power sources to maintain essential plant operations and safety system during power outages. Next point is security and safety measures. This point is very essential to each and every types of nuclear power plant. Various security features and protocols to protect the plant from unauthorized access, accidents and potential threats. These are, let us discuss what is security measures or which types of security measures we use. That is physical security, armed guards, intrusion detection systems, cyber security, background checks, emergency response plans, coordination with law enforcement, air space restrictions, security drills and exercises. Different safety measures we also use. These are as following as design safety, reactor control, emergency core cooling systems, containment building, radiation monitoring, emergency evacuation plans, safety reviews and inspections, seismic and natural disaster preparedness, safety culture, training and education, public information and communication. So, security and safety measures are very important for nuclear power plant. This is the main diagram of nuclear power plant. In this diagram, different elements, different components are used. We have discussed different types of components, elements which are used in nuclear power plant, and we have already discussed about this diagram. If you see the main diagram, control rods, pressure vessels, water pumps are there. This is the nuclear core reactor. If we compare the steam power plant or gas power plant, instead of nuclear reactor, in steam power plant, steam is used with the help of boiler, steam is generated. So, nuclear reactor is the main components of the nuclear power plant, and remaining other components like turbines, condenser, cooling tower, which is also used in steam power plant. So, that is the basic difference of the nuclear power plant and steam power plant, and from this cycle or components we can easily generate the electricity in an efficient manner. So, this diagram is very important for clearly understand the components of nuclear power plant and I already discussed what is difference between steam power plant and nuclear power plants in a very small manner. This is the main diagram of nuclear reactors. In this session, we mainly focused the nuclear reactor parts, that is biological shield, reflector, reactor, control rods, heat exchanger, moderators, coolants. If we change this moderator, coolant, different types of nuclear reactor we used according to their design, fuel used, coolant, moderator. So, nuclear reactor is very important part of the nuclear power plant, and we discussed all types of elements is used in this nuclear reactor. So, let us discuss about the conclusion. These elements work in a synchronized manner to produce controlled nuclear reactions, generate heat and convert that heat into electricity, all while maintaining safety and preventing the release of harmful radioactive materials. So, in this video session, we discussed about nuclear reactor, different types of nuclear reactor elements we have seen in our diagram, and steam turbine, steam generator, condenser, cooling tower, feed pump are used. So, we discussed all different elements of nuclear power plant and nuclear reactor. So, I hope you can easily understand the what is and which types of elements of nuclear power plant is used in our nuclear power plant. So, this is the main conclusion of our elements of nuclear power plants. In next video, we will discuss about classification of nuclear power plants, different types of nuclear plant. These types of nuclear power plant varies with the use of moderator, coolant and capacity required and all types of requirements. So, we will discuss this topic in our next video session. Thank you.